Hello everyone. Uh, Today we are going to do a different topic altogether, and this entails number patterns. So, what are number patterns? How do we see number patterns? That is the pattern in numbers. Where do we see these patterns in real life situation? If you look at a farm, you will find um, there are fields filled with sunflower. Now, if you go there, pick a sunflower seed, that comb, and then check the pattern there, you will find that there is a pattern that is followed. So that pattern is called a Fibonacci pattern. And what is that? Now, a pattern is found in nature, and some are created by human beings. Now, in nature, as I've said, we get sunflower seeds, patterns of the flower, that is the petals, the number of petals. And then here we have 1, 2, 3, 5, 8, 13, and 21. If you look at these numbers, there is a pattern that is followed in order to have successive numbers. Like, let's start first with this one. It's 1. When you add 1 and 1, you get 2. When you get 2 and when you add 2 and 3, 1, you get 3. 3 and 2, you get 5. 5 and 3, you get 8. 8 and 5, 13. 13 and 8, 21. Now, what is the pattern that we have been doing here? 1 step forward, and then you go back 1 step, and then you add. This you'll see here. 2, and then go back, plus 1, that gives you 3. Then you jump to the next. The same applies to this. You go back, that will be 2, and then 3, that gives you 5. You go back again, it's 3 plus 5 plus 3 gives you 8. You jump the 5. Go back, it's 5, and then jump the 8, you get is 8 plus 5, that gives you 13, and so on. Now that is how Fibonacci pattern is derived. So we now have the man-made patterns. If you look at the clothes that we wear, they have a certain pattern. The chairs that we sit on, they have a pattern. Everything on this planet is based on pattern. The cells, they have patterns. So let us just check this. When you cook, let's take cooking. How to make tea. You take 1 teaspoon sugar, 1 tea bag, and 250 milliliters of hot water. These are numbers, guys. These are numbers. They are numbers. So if you want to increase the number of cups, you are going to increase these numbers. So that is, this forms patterns. Now, how can you spot a pattern? How do we spot a pattern in a sequence? Now, what is a sequence? A sequence is a list of numbers following a certain pattern. Now let's get here. We have this sequence 2, 4, 6, 8, and 10. Now what is the difference between 1, 6, 11, 16, 21, and then we have the 3 dots behind 21. But here in the first sequence, there are no 3 dots. What is the difference between this sequence and that sequence? Let me explain. The first sequence, that is 2, 4, 6, 8, 10, is called a finite sequence. That means it ends here. It's finite. But in this is an infinite. That means it continues up to infinity. So the third as well as the fourth are also infinite. So let us put the sequence in the first. You have 2, 4, 6, 8, 10. What do you notice? One will say they are multiples of 2. That is correct. And one will also say if you add 2 to the previous term, you'll get the next. And that is also correct. Now, how do you get that 2 that you add? Look at this. If you take 4, subtract 2, you get 2. 6, subtract 4, 2. 8, subtract 6, 2. 10, subtract 8 is 2. Now, what do you realize about the difference between two successive terms? It is constant. Now, if it is constant, we know that that is a pattern that is called linear pattern. Now, what is a linear pattern? A linear pattern is a pattern where you have a constant difference added. In a linear pattern, you always, to get a successive term, you always add a constant difference, which is denoted by the letter D. The letter D. Now, we also have some patterns which are called geometric. That is, if we take for an example, 2, 4, 8, 16. If you look at that, you take the second, divide by the first, you will get a constant ratio. Now, those are called geometric sequences. In a geometric sequence, you must know that this is an exponential sequence. That one is linear. Some authors will call it arithmetic sequence. Arithmetic is the same as linear, then geometric is the same as exponential, and we also have quadratic. So, but for quadratic, you don't do quadratic in grade 10, guys. You are only going to do linear as well as geometric. Now, let's start first with the linear pattern. Now, what is a linear pattern? I said a linear pattern is a pattern in which to get the second term, you have to add a difference to the first. Like you had 2, 4, 6, 8, and when you subtracted, you got 2, 2, 2. And these are constant, it doesn't vary. So in order to get, look at that, term number 1, add this difference, it gives you term number 2. 2 plus 2 gives you 4. 4 plus 2, 6. 6 plus 2, 8. Now look at the pattern, the movement. That is the movement. That is why here I showed you this pattern. It's term number 1 plus the constant difference, it gives you term number 2. Term number 2 plus the constant difference gives you 3. For the same as in the third. So how do we denote that? We denote that by D is equal to term number 2 minus term number 1, which is also equal to term number 3 minus term number 2, and it's also equal to term number 4 minus term number 3. Now look at that. 4 minus 2, that gives you 2. 6 minus 4, 2. 8 minus 6, 2. Now, that's it. Now, I try to simplify this by using my own design. Look at this, how it works. Term number 1 plus D gives you equals term number 2. And term number 2 plus D equals term number 3. Let's use that using the numbers. We have seen that there's a difference of 2 between two successive terms. Now, that is our D. Now, the first term plus D equals second term. Our second term is 2. 2 plus 2 gives you 4. 4 plus 2 gives you 6. And then this works together, guys. Now, we come to a realization that term number 2 is equal to term number 1 plus D. And term number 3 is equal to term number 1 plus D, which is equal to term number 1 plus 2D. Why? Because D plus D, these are like terms. And then when you add them up, they will give you 2D. So it goes without saying that term number 3, let's start with term number 2. Term number 2 is equal to term number 1 plus D, and term number 3 will be equal to term number 1 plus 2D. So look at the sequence that is happening here. How many D's do we have? This is T1. In all this, T1 is constant. Now look at what varies. The D's, the number of D's varies. Term number 2, we have 1D. Term number 3, we have 2D's. Term number 4, we have 3D's. That means that what is the relationship between 4 and 3? 3 and 2. It means from this term number, you are just going to subtract 1 in order to get the numerical coefficient of D. So here we have the term number is n. So our numerical coefficient is going to be n minus 1. Then you multiply that by D. Now in some books, you'll get this D behind. I don't like that. Why? Because most of the people, they make mistakes if you have D as a negative. So I will prefer you to write it in front of n minus 1. So this is called the general formula. If you are supposed to calculate any term of the sequence where you have the D as well as your first term, you have to use this. Now, here comes the task. It says, determine T5 in each sequence. The first sequence is 3, 5, 7 up to infinity. Then 4, 9, 14 up to infinity. 23, 30, 37 up to infinity. Now let's look at the first solution. The solution of the first one. I'm not going to do the third. You are going to do it. So let's check. Let's check. Our first term is 3, and then our constant difference is T2 minus T1, which is 5 minus 3, and that gives you 2. That is your constant difference. Now Tn is equal to 1 plus d into n minus 1. Now our term number 1 is 3. We substitute that by 3. And then d is 2. Now our n is 5. We are supposed to find term number 5. 5 is our n. We substitute it. It's 4. 5 minus 1 is 4. 4 times 2 is 8. Then we drag that 3 down. That will be 3 plus 8. That gives you 11. So our term number 5 will be equal to 11. That's it, guys. So let's go for solution. The solution for the second question. Our first term is 4, and then our d is 9 minus 4, which is term number 2 minus term number 1, and that gives you 5. So our Tn, which is the general formula, states Tn is equal to T1 plus d into n minus 1. Then term number 5 is what we need. Our n is 5. And then T1 is 4. Then here we have plus 5, which is the constant difference. And then 5, which is n minus 1. Then that gives you 4. 4 multiplied by 5 is 20. Then plus 4. Then term number 5 of that sequence will be 24. So guys, this is it. This is it. So let's go for the next page, which will be our last one. We all know, guys, after every lesson, you must get work to do. So go to your Google Classroom and then check book 1, which is on your Google Drive. It is ebook 1. If it's not, check all those books. And then go to Siyavula ebook, page 66, number 1, exercise 3, then number 1 to 4. I need that done and submitted via Google Classroom. Thank you. This marks the end of our lesson, and we will continue with sequences and series the next lesson. Thank you.